What is atomic absorption spectroscopy? It is also called AAS, and it is a technique for measuring the concentration of metallic elements in different materials. As an analytical technique, it uses electromagnetic wavelengths coming from light source. Distinct elements will absorb this wavelength differently. Application of AES. It is utilized across many industries, and it is instrumental in the detection of metals with a sample. As such, this process is commonly utilized in pharmacology, archaeology, manufacturing, mining, and forensics. The application of AES in agriculture is that it analyzes the light emitted from a sample rather than light absorbed, are frequently used in various fields of agricultural study. Typically, they're used to identify and analyze the presence of potentially harmful elements in the environment. While in the forensics, uh, using this technology, forensic scientists can perform a depth analysis of blood samples, brain and muscle tissue, and gunshot powder residue. So, how is AES used in environment? In an environmental laboratory, atomic spectroscopy techniques are used to determine the composition and concentration of regulated metals in environmental samples, waters, wastewaters, soils, sludges, and waste materials. Atomic absorption spectroscopy requires the conversion of the sample to gaseous atoms, which absorb radiation. In AES, the sample is most commonly introduced as a solution. The solution is drawn into a small tube and taken to the nebulizer, where the solution is broken up into a fine mist. So this is similar to an aerosol can. The defined mist is carried to the atomizer, such as flame, by a carrier gas. When the mist reaches the flame, the intense heat breaks up the sample into its individual atoms. This final process is called atomization. So, atomizations, there are two main types of atomizers: a discrete and continuous. A continuous atomizer introduce the analyte in a steady manner, whereas discrete atomizers introduce the analyte discontinuously. The most common continuous atomizer in AES is a flame, and the most common discrete atomizer is the electrothermal atomizer. Sample atomization limits the accuracy, precision, and limit of detection of the analytical instrument. The purpose of the atomization step is to convert the analyte to a reproducible amount of gaseous atoms that appropriately represents the sample. Electrothermal atomization. During this, a sample goes through three phases to achieve atomization. First, the sample is dried at a low temperature, then the sample is ashed in graphite furnace, followed by a rapid temperature increase within that furnace, where the sample becomes a vapor containing atoms from the sample. Absorption is measured above the heated surface where the sample was atomized. A graphite furnace is made up of a graphite tube open at both ends with a hole in the center for sample introduction. The tube is encased within graphite electrical contacts at both ends that serve to heat the sample. A supply of water is used to keep the graphite furnace cool. An external stream of inert gas flows around the tube to prevent outside air from entering the atomization environment. Outside air can consume and destroy the tube. An internal stream of inert gas flows through the tube, carrying away vapors from the sample matrix. So, it provides enhanced sensitivity because samples are atomized quickly and have a longer residence time compared to flame AAS systems, which means more of the sample is analyzed at once. This method can also be used for quantitative determination based on signal peak height and area. Uh, Also offers the advantage of small sample size and reduced spectral interferences because of the high temperature of the graphite furnace. However, electrothermal atomizers have disadvantages, including slow measurement time because of the heating and cooling required of the system and a limited analytical range. Additionally, analyte and matrix diffuse into the graphite tube, and over time, the tube needs replacing, increasing maintenance and cost associated with electrothermal atomization. So what are the advantages and disadvantages of AES? The advantage of AES, based on experimental work, it includes a high degree of sensitivity, freedom from interference from other metals present, while the disadvantages, only solutions can be analyzed, less sensitivity compared to graphite furnace, relatively large sample quantities are required 1 to 3 ml. Problems with refractory elements. That's it. Thank you.